Okay, in this video we are doing Calc AB Problem Set 95. The problems and a playlist are in the description below. Let's take a look at the problems. Number one, evaluate. So we got a couple of antiderivatives or integrals that we want to find. So the first one is sine of square root of x over the square root of x. So I mean the only chance you're going to have here is to do u-substitution, right? Try to make it into just sine of u. So if that's the case, then I'm going to say u is the square root of x. So u is the square root of x. Anytime I have to find dx, I like to get kind of x by itself first. I don't want to take the derivative of the square root of x. So I'm going to square both sides to get u squared is equal to x. From there, I will get 2u du is equal to dx. So I didn't want to deal with the square root of x. There's a way around that, just square both sides. So that's what I've done. Now I'm going to try to rewrite the integral all in terms of u. You can see there's a lot of square roots of x. So there. And then we also have to deal with dx. So just don't forget any of those, you'll be okay. All right, so it's going to become sine of u. The denominator is u. And then dx is 2u du. If that 2u du wasn't there, the 2u in particular, we'd be in trouble because sine of u over u is a pretty complicated situation that we definitely don't know how to handle yet. So we're going to cancel the u's, right? And then pull the 2 out. So we'll have 2 integral sine of u. Integral of sine takes us to negative cosine, so we get negative 2 cosine of u plus c. And then u is equal to the square root of x, so negative 2 cosine square root of x plus c. Pretty good problem. All right, for the next one, I look at this and I think, is this just normal u substitution? If so, u would be 9 minus x to the 6th. But then I would get du is negative 6x to the 5th dx, and I do not have x to the 5th. So now I start thinking, what do I know that has a radical in the denominator? Well, there's definitely a radical in the denominator of the derivative of arcsine. I forgot the plus c there, but it was more the idea than solving it, so I'm okay with that. So I think this is arcsine. So now my objective is to make it look like du over square root of 1 minus u squared. If that's the case, I got to get this 1, right? It's square root of 1 minus, and right now it's square root of 9 minus. I'm going to factor 9 out of everything in the denominator, which means that I will get the square root of 9 is 3. So there's a 3 being pulled out of the denominator, and that will give me a 1/3. And then inside the denominator, I'll have 1 minus x to the 6th over 9, but I know that that's u squared, so u is x cubed over 3. So the quantity x cubed over 3 squared. So I'm just rearranging this so it looks like arcsine. Rearranging so it looks like arcsine or arctan, definitely a skill you want to brush up on every once in a while. So doing this, I've now got u is x cubed over 3, which means that du is going to be x squared dx, which is perfect because I have x squared dx. So I'm going to make all my substitutions now. 1/3 x squared dx becomes just 1 du. Our denominator becomes the square root of 1 minus u squared. This is perfect arctan, so it's good. Arcsine, sorry. 1/3 arcsine of u plus c, and then u is equal to x cubed over 3, so there's our answer. All right, let's take a look at the next problem. Use the graph of f of x shown above to answer the questions that follow. So we want to state the x-coordinates at which f of x, so the actual graph that we're looking at, is not differentiable, and state a reason. This is kind of an unusual question because usually you're asked about, given the derivative and ask a question, or ask the question about the derivative, which I guess we are here because we're looking for it. The derivative would fail to exist. So I'm going to circle them. We got there. That's a lot, right? They're all sharp turns, or corners, you might say. So I'm just going to list them. So I'll say f of x is not differentiable at x equals -4, -2, 0, 2, and 3. I need to give a reason, so I'm just going to say the sharp turn thing because we have the graph of f, so why not? So because f of x has sharp turns at these points. I think that's an okay answer. There are so many of them that you don't want to get into one-sided limits of derivatives or anything like that. This is perfectly good. All right. B, given that g prime of x equals f of x. So now we're looking at the graph of the derivative. Find the x-coordinate of the absolute maximum of g of x on the interval -6 to 4 and justify. All right, so we're looking for the x-coordinate of the absolute maximum. So that's either going to be at an endpoint or at a critical point. Look at the critical points, though. There's a critical point at -1 for sure, but there's no sign change there. There's a critical point at 1 because the derivative is 0, and there's a sign change. And the sign change is from positive to negative, which means the derivative goes positive to negative, the function goes increasing to decreasing. That's a relative maximum, and it's the only critical point at which we have a sign change. So you have a relative max at the only critical point with a sign change. That has to be the absolute max. So now all we have to do is really write up what we've said. So the only critical point at which g prime has a sign change is x equals 1. That's the only place there's a sign change. Now at x equals 1, g prime, which is f of x, changes from positive to negative. So that means we definitely have a relative maximum for g of x at x equals 1. Now we just need to say that it's the absolute maximum, and our reasoning is there's only one critical point at which this could happen, and it is a relative maximum, therefore it must be the absolute maximum, right? Look at the derivative there. The derivative is always greater than or equal to 0 when you're to the left of 1. Then the derivative is always less than 0 to the right of 1. So the function goes from increasing to decreasing only at 1. It has to be the absolute max, so I'm going to write that down. Since g of x has one critical point with a sign change and a relative maximum at that point, g of x has absolute maximum at x equals 1. That's our answer. All right, let's look at the last parts of this question. We want to evaluate the integral from -6 to 4 of f of x dx. Sometimes I get these wrong, so you should definitely check my work on this. But I am thinking we just need to do like some geometry stuff. So this is a 2 by 3, which is 6. Then we have a 1 by 2 and then half of a 2 by 2. So that's going to be 4 in total in this region. Now this next part is a little weird. We have a 1 by 2 rectangle, and we're subtracting half of a circle that has a radius of 1. A circle with a radius of 1 has an area of pi, so we're subtracting pi over 2. So I think overall this is 2 minus pi over 2. That's the hard part. The next two little triangles that you see should cancel out, right? They're exactly the same size, but on opposite sides of the x-axis, right? One's above, one's below, so they'll just cancel. And then here we have a rectangle that has an area of 3, a square with an area of 1, and then a triangle with an area of 1. So 3, 1, 1, 5 overall, pretty sure. All right, so our integral from -6 to 4 of f of x dx is going to be the sum of these numbers, right? So it's going to be 6 plus 4 is 10, plus our weird little bit there, and then just plus another 5, because that one region cancels out. This should be -5. Oh, error, unforced error. Hold on, I got to fix that. I'll fix it in red, because that's what we do with mistakes. Minus. Man, thought I'd double check these. But you know, it's like, I don't want to say that checking is not worth it, but it's like, I had it in my head that it was right, so I just like thought it was right. So I'm going to have to change the next thing. So that's 12 minus 5 is going to be 7, and then minus pi over 2. Got to change that. You know what I'll do? I'm just going to delete that one. There we go. 7 minus pi over 2, just like we thought it was. All right, and then we have to evaluate the integral from -6 to 4 of f prime of x dx. So this is literally the fundamental theorem, right? If you integrate f prime, you get f, and then we'll evaluate it at 4, evaluate it at -6, and subtract those. So this is the fundamental theorem. We're going to do f of 4 minus f of -6, and then we can read those values off of the graph. But this is literally the fundamental theorem. It's pretty straightforward. It's always a little, you don't expect to just have to do straight up fundamental theorem on these types of things, but it's pleasant when you can. So if you look at the graph, f of 4 is down here at -3, and f of -6 is up here at +3. So we're doing -3 minus 3, -6 overall. I think that's it. I hope this was helpful, and good luck.